Welcome back to College Algebra, and we're continuing our series on the basics of college algebra. Today, we're talking about multiplication with fractions. And we're going to get to this, but similar to addition, the main point of multiplication of fraction is that when we multiply both the numerator and the denominator across to get our final answer. But just as in other topics, I don't want to just memorize a fact and use it. I want to understand why the fact is true. Because understanding the fact will make it where we don't have to memorize it. What you'll find is that people who do a lot of mathematics don't spend time recalling facts. Instead, they understand the principles, so the facts seem obvious and apparent to them once they go through the problem. Okay, let's start with a problem. We'll start with a fairly simple one. But what is a fourth times a half? And how should I think about this problem? Well, here's how I think we should think about it. We should think about it as when we say 1/4 times 1/2. Multiplication is kind of a creating groups. So if you say what is 2 times 4, you say we have two groups of 4. So in this case, what we're really saying is what is 1/4 of a group of 1/2. So we have a half, and we're asking what is 1/4 of it. And I think the best way to represent this is to represent this with a picture. So 1/2 is quite simply just this 1/2 of our whatever our object is. So this part here that I'm kind of highlighting in blue. So this part right here is our 1/2. And so the question is, what happens if I take that 1/2 and divide 1/2 into 4 pieces? What is 1/4 of 1/2? And the answer is we divide that 1/2 into 4 pieces, and you can see that one of those pieces is this size right here. And so this size right here is what you get if you take a half and split that half into 4 pieces. Now, hopefully you're following along. It already makes sense that if we were to do that on both sides, you would see that this piece must be a piece that is the size 1 out of 8. And so what you see is that when you multiply a fourth times a half, what we get is 1/8. Now this is important because if you'll remember from last time or from previous when we talked about fractions, it's always important to realize that the numerator is telling us how many we have, and the denominator is telling us what type we have. And so notice whenever you take a type that's a fourth and a type that's a half and multiply them, you end up with a type that's 1/8. And it should make sense that whenever we do any sort of multiplication, the type that we're going to get is going to be the type that results from multiplying the denominators together. So this brings us to our basic principle. Our basic principle is that to multiply fractions, we have to multiply both the numerator to tell us how many of the pieces we have altogether, and we have to multiply the denominators to tell us what type of piece we have. So the type we have is now an eighth. The type is a result of splitting the half into fourths. Let's look at a problem, and first we'll answer the problem using our basic principle, but then I want to spend a little bit more time just explaining why this principle should be true and how we can come to understand it. Well, so first, our principle is just to multiply fractions. We multiply both the numerator and the denominator. So as I look through this problem, what I see is that the numerator is 3 and 7, so this is how many pieces we have, and in total we have 21 pieces when I put these two fractions. But what type are those pieces? Well, the types are what we got when we took halves and split them into fourths, and so the types are eighths. And so if we look carefully, what you can kind of see is you can see that we took the 7 and the 3 and multiply them together to get the 21, and then similarly we took the 4 and the 2 and multiplied them together to get 8. And so multiplication works really nice in this sense that whenever we want to multiply, all we simply do is multiply across the numerator and multiply across the denominator. So in some ways it's much easier than addition because there's no finding common denominators than does this extra calculating. I want to talk just a minute for why we should expect this to happen, and the reason comes to interpreting what this 7 divided by 4 means. And one way I might interpret why this is the case again, we've already suggested and talked about it, but I might say, why is this the case? Well, I might say 7 over 4 is the same as having 7 pieces of size 1/4. So it's the same as 7 times 1/4. And this is an important idea that we're going to come to later in the semester, that numbers, a number multiplied out front and a number in the numerator, are actually playing the exact same role in the problem. Because the numerator tells us how many. Well, if you multiply a number out front, that also tells us how many. That tells us we have 7 of these things. We have 7 1/4. And then over here, what do I have? I have 3 of my 1/2 pieces. So multiplying out front says I have 3 of them. A numerator tells me I have 3 of them. I have 3 1/2 pieces. Now what's important is when we do multiplication, we have a very important rule, and the important rule is that we can reorder multiplication and end up with the same answer. So this is what we call the commutative property of multiplication. We can reorder those in any way we want, and so I'm going to reorder them so that I multiply the 7 times 3 together first, and that I multiply the 1/2 or 1/4 and 1/2 together second. And so what you see is I regrouped these, grouped the 7 and 3 together, and grouped the 1/4 and 1/2 together, and the 7 and 3 tell me that I have 21 total objects, and the 1/4 and 1/2 tell me that 1/8 is the type of the object that I'm dealing with. So 21 over 8 is my final solution. Notice this is the same answer I got earlier, so our process works. But again, I feel like you're in a danger zone if all you're doing is memorizing a rule and trying to apply it, because our memory fails us. Understand the way multiplication works, understand what fractions mean and what these terms mean, and then it might make sense that multiplying across is the right thing to do when we multiply. Let's look at another problem. We'll solve this problem twice. We'll do it once just the way we did, and then I'll show you some shortcuts that we can do whenever we start multiplying. So the first thing we might realize is that when we solve this problem, we can do the exact same thing. That is, we can multiply across and multiply across. And so we can multiply across 5 times 14. I'll let you work that out at home, but the answer is 70. We can also multiply 7 times 15. I'll let you work that at home, but the answer is 105. So we end up with 70 divided by 105. Now this is a reasonable answer, but we're often much happier when we can reduce the fraction. It makes it a little bit easier for us to think about and to reason about. So what I'm going to do to reduce this answer is I'm going to first divide both by 5, because I've noticed that they are both obviously divisible by 5. And what I end up with on top is 14. And what I end up on the bottom is 21. Now, I notice 21 and 14 are both divisible by 7. So that's divisible by 7, and that's divisible by 7, and it looks like I end up with a 2 on top and a 3 on bottom. So 2/3 is a much more pleasing to the eye answer than 70 over 105. This is quite reasonable. You can always do multiplication by multiplying the numerator, multiplying the denominator, and getting your fraction. And then we often want to reduce the fraction, so you can reduce using the ways that we've reduced all along. However, let me show you an alternate version of this. The alternate version is, what if we do this reducing before we start? What if we do this reducing before we started the problem? So what if as we started the problem we realized, oh look, when we multiply across, we're going to have the top multiplied by 5, and we're going to have the bottom multiplied by 15. So we might recognize that this 15 is the same as 5 times 3. Now what's going to happen is we're going to have 5 multiplied by both the top and the bottom, so those two 5 pieces can be canceled out. Now I'm always resistant to use the word canceling. What really happens is that 5 divided by 5, fractions do after all mean division, the 5 divided by 5 makes the number 1, and the number 1 has no impact on the problem. But what you see is that this 5 and this 5 are going to reduce with each other. We would have divided out the 5 whenever we got to this step, and it wouldn't have been there anymore. So basically we're doing this step of the simplification right now before we do any multiplying. Let's do the same on the top. realize that 14 is the same as 7 times 2, and then recognize that after we multiply across, we'll have 7s in both the numerator and the denominator, and those 7s will cancel. The 7s will divide together to make 1. In other words, when we multiply across, we'll end up with this step where we divide by 7 out to get our problem. Now, notice what I have left. What I have left in the numerator is I have a 2, because my 5 has been divided by this 5, my 7 has been divided by this 7, and the 2 is the only thing in this numerator that hasn't been divided out. Similarly, for my denominator, the only thing that hasn't been divided out is the 3, and so I end up with 2/3. So this is an alternate method. You may find this easier. This will actually be a very good method for us later in the semester when we start simplifying more complex polynomials. We'll look for things that factor and cancel and make simpler situations than we began with. As usual, let's end today with a couple problems. So look at these two problems, pause your device, try to solve them, and then come back and I'll do them with you, and we'll see how successful you were. Okay, and we're back. Hopefully you gave those a really good effort, and let's look at each one individually and see what we can get for our answer. Let's look at this first problem. The first problem ends up being quite a bit simpler than the second problem because we simply multiply across. You multiply the 7 and 3 and get 21. You multiply the 20 and the 4 and you get 80. And this is as simple as it gets because there's no simplifying, there's no canceling going on here. This problem, there will be simplifying. What if I follow the trick that we did earlier? And that is, what if I follow the canceling trick? You could have multiplied and got 72 divided by 30 and then reduced that 72 divided by 30. But what if I try to do my reducing before we start? Notice that 9 is the same as 3 times 3. So I'm going to have one of those 3's divide by this 3 in the denominator, and 3 divided by 3 makes 1, which is simpler than what we started with. Now I notice that 8 and 10 are both even numbers. So 10 will be 2 times 5, and 8 will be 2 times 4. And now I notice that I can divide this 2 by 2 before we start. Divide 2 by 2, and end up with just the 4 and the 5, because the 2 by 2 make 1. As I look across, I multiply across my numerator. I have 4 and 3 remaining, so I have 12 remaining in my numerator. I have only 5 remaining in my denominator, and so 12 divided by 5 is my solution. Well, I hope that went well. Good luck. Next time we'll talk about division, which is kind of a close friend to multiplication.